Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to be kind of an introductory video on exponential functions here. So what we're going to do is we're going to take a look at this function here, y equals 2 to the x, and we're going to graph it. And what makes this an exponential function is that the x here is in the power. So we're going to go ahead here and build ourselves a little table here of x's and y's and just sketch a quick graph of this thing. Alright, so let's just do some easy points here. Let's do 1, 2, 3, see where that takes us here. So when we put 0 in, this is going to read 2 to the 0, which is 1. And when we put 1 in, 2 to the first is 2. And when we put 2 in, 2 to the second power, 2 squared is 4. And this one I'll go ahead and write out. When we put 3 in, right, y is going to equal 2 to the third, and 2 to the third is 8. Let's start plotting these here. So, right, 0, 1, 1, 2, 3, 1, 2, 3, 1, oops. Oh, did I skip one? 2, 4, sorry. 1, 2, 1, 2, 3, 4. And then 3, 8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And if I try to do 4 to the fourth is 16. That's way off the graph. That's way, way up here somewhere. So I'm just going to stop here and start kind of looking at what's going over to the left here. So let's try some other points here. Let's try putting -1 in. So -1, and I'll write this out. Y is going to equal 2 to the -1, which is 1/2. So -1, 1/2 is just, barely over the axis here. I think we'll just put a few of these points over here. Some more x's and more y's. Normally you would want these in one table, but all right, let's put -2 in for x. And y is going to read 1 over 2 squared, which is 1/4. So -2, 1/4. And if we put -3 in, right, we're going to get 1/8 out of that. 1, 2, 3, and 1/8 is barely above the axis. And as we keep going, -1/4, -1/5, -4, -5, -6, what we're getting is smaller and smaller and smaller values. They're getting really close to the axis. 1 over 2 to the fifth is 1/32. I can barely, that's not even the width of the pen here. So let me just kind of sketch this here. And there's a graph of f of x equals 2 to the x. Now, let's talk about some general properties of it. First of all, you'll notice there's no value you can put in for x and get a negative number out of this. Right? So this graph, none of it is down here. So let's go ahead and talk about range here of this function. You'll notice that all these function values are positive. So y has to be greater than 0. Let's talk about the equality for a minute. You might wonder, does it get equality? Well, there really is no value you can put in for x and get a 0 out of this either, right? There just isn't. It's getting closer and closer to the axis here, but even if you put -1 trillion, -1 trillion to the trillionth, you're still not going to get identically 0. So the answer to the equality is no. It does not get an equality on it. So the range is y is strictly greater than 0 for this function. Let's talk domains here. All right, so any value you put in for x is going to be good. You can put anything you want here, you're going to get a number out. So the domain of this thing is all real numbers, which is our shortcut for that. So this is an example of y equals 2 to the x. If you were to graph y equals 3 to the x, it has the same type of shape. It just gets bigger a little faster. Y equals 5 to the x gets bigger a little faster. Y equals 1.1 to the x would just get bigger a little bit slower. Anything that is in this form, y equals a to the x, where a is bigger than 1, will have this type of shape to it. It will go through the point 0, 1, and it'll get bigger as we go to the right. The domain of anything that looks like this will be all real numbers. Range will be y greater than 0. Let's take a look at another one here. I think I've got. Let's look at 1/2 to the x. We're going to do the same thing here. Right, x, y's. Let's start with 0. So 1/2 to the 0 is 1. Put 1 in. 1/2 to the 1 is 1/2. put 2 in. 1/2 squared. Now if I write that one out, right, that's 1/2 to the second power. 1 squared is 1, 2 squared is 4. So when we put 2 into this function, we get 1/4 out. When we put 3, we get 1/8 out. And hopefully we can start to see what's happening already. Let me plot some of these points. So 0, 1 is here. 1, 1/2 is 1 over and half up. Notice we're real close to the axis. 2, 1/4. 1, 2, and 1/4 is barely over the axis. 3, 1/8. Oops, point disappeared on me. 3, 1/8 is barely above the axis here. Now it's getting to the point where the pen isn't thin enough for me to get close to show this, but basically what we're doing is we've approached the, whoops, do that a little better than that. We've approached the axis is what's happening. Now it never gets below this, it just gets really, really close. Take a look at a couple points on the left, like maybe -1. Now if I write this out, that's 1/2 to the -1. Now when we apply the minus sign, that's 2 over 1 to the first, which is 2. So -1 and then 1, 2. Let's try the -2 here. And that's going to be 1/2 to the -2, which is 2 over 1 squared, which is 4. So -2 and then 1, 2, 3, 4. And if we put -3 in, we're going to get 8 out of that. Way up here. Now I can kind of sketch this. So 1/2 to the x has the same type of shape of 2 to the x. It just it gets big going to the left and goes to 0 going to the right. Domain of this function is again all real numbers. You can put anything for x in that you want. You're going to get a value out. The range of this function is y greater than 0, and no equality again, because there's no value of x you can put in and get identically 0 out. Right? So just kind of a generic description here is anything that looks like y equals a to the x. Whoops. Get rid of that. Oops, come on. Anything that looks like y equals a to the x, if a is between 0 and 1, like a fraction, like 1/2, 2/5, 4/7, right, then it will have this type of shape. It'll get big over on this side, go to 0 over here. Domain will be all real numbers, and range will be 0 to plus infinity again. All right, let's do one more here. Do a quick sketch of y equals 3 to the x. X, y, let's do this. Let's go -2, -1, 0, 1, 2, 3. I don't know that we'll get the 3 in, but all right, when we put -2 in, this is going to read 3 to the -2, which is 1 over 3 squared, which is 1/9. So 1, 2, and 1/9 is barely above the axis. All right, -1. That's going to be 3 to the -1, which is 1 over 3. So -1, 1/3. Again, kind of barely above the axis. This one probably should have been a little lower. Okay, 0. 3 to the 0 is 1. 1. 3 to the first is 3. 2. 3 squared is 9. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. We're not going to get the other one in here. 3 to the third is 27. It's way up there. So you get a sense here. Again, if I go to -3 or -4 or -5, it just approaches the axis. So I'll just try to sketch this like so. And again, it just gets big really fast. Close enough. All right. What else we got here? 1/3 to the x. So hopefully now you could probably sketch this on your own after watching this, but let's try a couple values here. So let's try -2, -1, 0, 1, 2. Now, I'm going to write one of these out and then I'm just going to fill out the rest. When x is -2, y is going to read 1/3 to the -2, which is 3 over 1 squared, which is 9. And then this one is going to be 3. And when we put in 0, we get a 1, 1/3, 1/9. And I'm just, again, filling these out by putting values of x in and calculating numbers. -2, 9, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. -1, 3, 0, 1, 1, 1/3, 2, 1/9. Now that's barely above the axis. If I go to 3, 4, 5, I can't, my pen's not even thin enough to distinguish, so I'm going to go ahead and just start sketching this. And again, it approaches the axis. Looks something like that. So there's a graph of y equals 1/3 to the x. And again, as promised, when your a value is between 0 and 1, you get this type of shape. Domain of this function is all real numbers. Because you can put anything for x in that you want, you're going to get a number out for y. And then the range of this function, all right, so we look at our graph here, you notice there's nothing down here. All these y values are all greater than 0, so that's our range, y greater than 0, strictly greater than, no equality. So this was just meant to be an introductory video to exponential functions. I think I think I will leave that right there. So I hope this video helps demonstrate how to graph an exponential. Have a great day.